All right, let's take a look at our lesson for today. We are going to be working with, it's called, the section in our textbook is called Mathematical Models. Basically what we're doing is we're going to be working with word problems. These types of word problems that are in this section are a precursor to optimization problems in calculus that you will be working with next year. So how does that work? So let's work through and see how that works. So okay, so we've got the first problem. We're going to let P equals xy be a point on this graph. They've actually already given us a graph of it. And they want us to express the distance d from P to the origin. So we're looking at from here to here, the distance from the origin to P as a function of x. Okay, so let's hold there for just a second. We need to think back to your memories. We need a formula for distance between 2 points. Okay, so hopefully you remember that formula. I'm just going to write that formula down. If you recall, it's like the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So one of our points is 0, 0, and what I normally do, I kind of like putting, if we have a plain old point with numbers, I usually put that at the back number. Because I would rather subtract a number than a function. I just rather would. So that's what I normally put. So we're going to rewrite that and we're going to put 0, 0 as x1, y1. So there we go. So I've got x minus 0 squared plus y minus 0 squared. And since I only have one x and one y, I'm dropping the sub numbers. I don't need them anymore. Now the thing with this technique is, that makes it a little bit more difficult, I guess, is that we really aren't allowed to have 3 variables like that with doing this kind of thing. We really can only have 2. So what that means is that many times we have something that I call a helper equation. It's a helper equation. It's an equation that we can use to get rid of one of the variables. So let's look back up in the problem and see where our helper equation is. I see one right here. So that's our helper equation. It says that y is the same as x squared minus 1. So that's what I'm going to do. I'm going to insert that in place of y in my distance formula so that I can narrow this down to, just one variable, well, d and then another variable. So we've got x squared plus, in place of y, I'm going to put the x squared minus 1 minus 0, which of course doesn't matter. Now that's the equation that we need to work with. We're asked to find the local minimum and the closest point. So we have 2 things that we're working with. Now typically, could you put your equation that looks like that in your calculator? Yes, I'm going to go ahead and do some algebra, distribute and combine like terms. Could you leave it like that? Sure, and put in your calculator. That's fine. But I think it's fun. I know y'all know I have a weird idea of fun, but that's fun. So what am I going to do? I'm going to FOIL out the x squared minus 1. That's going to give me x to the 4th, minus 2x squared plus 1. Then cleaning that all up, I get x to the 4th minus x squared plus 1. Okay. All right, is everybody okay so far? So I have my distance equation formula, and which has an x and a y, which I can't deal with. I need either an x or a y. Doesn't matter which one. So I use my helper equation. I'm just going to write, this is a little name. I call it a helper equation. This is my little helper. My helper equation helps me get rid of variables that I don't want. Hopefully, I can't even spell helper. This is my helper equation. Okay. So let's go to our calculator. So let me pull up my calculator, and I need to be in the graphing part. Okay, so the square roots, where is it? Second. There it is down there. Square root. And so we've got x to the fourth, and then minus x squared, and then plus 1, and that's our equation that we're going to graph. Okay, so it's looking for the minimum value. I think you can see there are two minimums, one here and one here, two different minimum values. So I'm sure you probably recall how we do that. So I do menu, analyze graph. I'm looking for my minimums. So we'll just do this one right here. And that is my minimum value. Okay. I'm going to need to use this. I know that. So, well, I'll leave it. We'll just go look at the problem and then I'll show you what we're going to do. So that's my minimum value. This is the minimum y value, 0.866. And that's what they're wanting, is the minimum value, which is a y value. Okay, so the minimum distance is 0.866. That's one thing that they wanted, was minimum distance. Okay. So now they want the closest point. Let's see. So the closest point, the x value of that point we found in the calculator is right here. Right? That's my x value of the point. But this isn't the y value of the point. This is the minimum value. How am I going to get the y value of the point? Okay, so I know I've got points. So let's just write, so we have a point. The x value that my calculator gave me was 0.707. And negative, let's talk about that, 707. So looking at my graph, this is an even function, so each side is symmetrical. If you don't trust it, you can find the minimum here, but the minimum is going to be negative 0.707. Okay, that's what that minimum is going to be. And so that's what I'm doing. I'm writing down the minimum right here. So I've got these 2 points. How in the world, and I need the point. The point is on this curve. I need the y value of the point on this curve. So what am I going to do with the x value, this 0.707? What should I do? I should put it right in here, right? We want to put it in the parabola, and we want to determine what the proper y value is. So I'm going to go back to my calculator. I'm actually going to store this number. So I highlight it, and I do Control var, that's my store, and I'm going to call this A. So now everywhere I see this, it's an A. So I need a calculating screen, so second plus, here's my calculator screen. If I don't trust, I can just say A, enter, and see what it does, and it comes up with that whole number. Okay? What do I need to do with that whole number? I need to put it into y equals x squared minus 1. So I need, let's just do a squared. So that's my x squared minus 1. That actually took this number and stuck it in there. That's what me saving it as a did. And there's my y value, negative 0.5. If I put the negative one of these numbers in and squared it, it's still going to give me the same answer. Okay? So what we have is negative 0.5 and negative 0.5, and those are our closest points. All right, there's our very first optimization problem, or as they're calling them, mathematical models problem. How are we doing? Is everybody okay? Okay. So let's look at our next problem. Does anyone still need that? Okay. All right, we've got a parcel of land, has an area of 5,000 feet squared. A diagonal between the opposite corners is measured to be 10 feet longer than one side of the parcel. What are the dimensions? Correct to the nearest foot, so they want us to round to a whole number. All right, here we go. So let's draw our parcel of land. It's rectangular. We have a diagonal. So what I did is I called this side y and this side x. You can use whatever variables you want. You don't have to do the same ones I do. It's whatever you want. And it says that the diagonal is 10 feet longer than one side. It doesn't really matter which side you pick to be 10 feet longer than. It doesn't matter. I chose to be 10 feet longer than x. So 10 plus x. You could have chosen to be 10 feet longer than y. It doesn't matter. Okay? All right, great, great. What other information do we have? We've got the area is 5,000 square feet. So x times y is 5,000. I have two equations. Well, there's one. I need another one. One is not going to be enough. I won't be able to figure out what x and y are just with that equation. So I need another one. That's what I was saying before, is that these problems typically take two equations to solve. You need to find two different ones. I can see with the rectangle that I can set up a relationship between x and y using Pythagorean theorem. Okay, if I use Pythagorean theorem, I can set up another equation that involves x's and y's. So that's what I want to do. So this is going to be x squared plus y squared equals 10 plus x squared. Okay, great. We have two equations. So what our goal here is we have two equations. It's a system. We want to solve a system. I know these are weird looking equations. Some have squares and some, are just multiplying. They're weird, but we need to solve it. We have to decide which equation to solve for what. It's totally our choice. It's whatever we believe would be easier. Now, some may be tempted to take this equation right here, the area equation, and solve for x or y. You could do that, but it would create a fraction. And you'd have a variable in the denominator. That's really not how I want to go. I don't really want to do a fraction with that. So I'm really not going to solve for x or y there. Because again, I can only have x or y. I can't have both. I'm going to use this one and solve for x or y. That's what I'm going to do, just to try to avoid a fraction. I know maybe that's chicken. Maybe I'm being a chicken, but I really want to avoid working with a fraction like that, like 5,000 over x. I really don't want to do that. So let's go ahead and FOIL that out. So if I FOIL that out, I get, what do I get? I get x squared plus 20x plus 100. Okay, I can see that those x squareds will cancel. And so I've got y squared equals 20x plus 100. Now, it sure would be easy, like mathematically, to solve for y and square root both sides, but that would cause a plus minus square root on the right, and I do not want to deal with that. I really don't. I don't want to do a plus minus. So instead, I'm going to solve for x. That just seems the easier route to go. So I've got y squared minus 100 equals 20x. So I'm going to divide both sides by 20. So I've got 1/20 times y squared minus 100 equals x. Okay, great. Now I'm just going to distribute the 1/20. So it'd be 1/20 y squared. Let's see, 100 divided by 20 is what, 5? Okay. So now what I'm going to do is I'm going to take this and I'm going to put it right here. I'm going to replace the x with it. Okay, that's what I'm going to do so that I can get down to one variable, which happens to be a y, which is fine. It doesn't really matter. So let's do that. So I've got 1/20 y squared minus 5 times y is 5,000. I need to get this prettied up to put in my calculator. So I'm going to distribute the y and move everything to one side. So I've got 1/20th y cubed minus 5y. I'm going to move the 5,000 over, equals 0. All right, so this is the equation. This is the equation I'm going to put in my calculator. This is the one that's going to help me find out what y is, and then I can in turn find out what x is. Okay, so what is the process that we just went through? We found two equations that relate x and y together, and we solved one of them for x so that we can get rid of x in the other one. We're just solving a system. All right, so let's go to our calculator. And let's, I'm going to just go back up and erase that. So I hit tab and then scroll up so I can just get rid of that. Of course, y'all have different ways of doing it. You can do it in a new sheet or if you want to. All right, so I need to put in 1/20th. I like to put a fraction bar. Control divide gives me a fraction. So 1/20 times, your calculator doesn't care whether we use x or y, so I'm just going to use an x. I mean, I know it's a y, but I'm going to use an x. So that would be x cubed. And then what do we have? Minus 5x. And then minus 5,000. Now 5,000 is a big number. We're probably not going to be able to see anything when we hit enter. This graph is probably not going to be anywhere on this 10 by 10 or whatever, 6 by 10 rectangle. So 1/20th x cubed minus 5. Okay, so we're good. Okay, so see, I don't even see it. So there's all different kinds of ways you can see what we're looking at. I have the way that I like to do it. You probably have the way you like to. I like to go to menu, window. I like to change the window settings myself. Y'all might like to try zoom in or zoom out or zoom fit, any of those. You can play with all of those. I'm just going to fix it myself. So let's see. I want to be able to see it cross the x-axis, so I'm going to do my x maxes to, I don't know, maybe 150, or I'm just guessing. My y max, no, I don't need that. I need that. I don't care about that. It's the y min that I want to be at like negative 100 or something. Because my y max, I mean, we went to 5,000. I mean, what is this going to be? I don't even know. I'll put in 5,000. Who knows? I don't know. We'll see what we can see. Okay. All right. We can see part of it. We don't really see. It apparently goes on forever, so we're good. So when in my work over here, I set this equal to 0. So what I'm trying to find out is this, the zeros, right? I want to find this number right here. So let's do that. So we do menu, analyze graph, and we do zeros. So we want on this side and on this side, and lo and behold, there's our 0. This is the, and in our work, y value that we want right here, 47.134. Okay, great. I'm actually going to store it because I know I'm going to need to use it again. So control var, I'm storing it. I'll store it as B. It kind of freaks out when I try to store it as A, so we'll just store it as B. Okay. Is everybody okay? All right, so let's go back here. So I know my y. My y is 47.134. Okay, so what do I need to do? I need to put that in here so I can figure out what x is. So x times the 47.134 equals 5,000. That's what I'm doing. On my calculator, I'm going to do 5,000 divided by that 47 number. That's what I'm going to do on my calculator to solve for x. Okay, so let's go to our calculator. And we're going to do on this page. So I'm going to do, first of all, I just want to hit B, make sure it's in there properly. Yep, it's right there. There's B. So I'm going to do a fraction, and I'm going to say 5,000 over B. And then Control Enter, and there's my X value is 106.081. Okay, so here we go. So my X value is 106.081. Now they want the dimensions to the nearest foot. So we would say that it's 47 feet by 106 feet. And there's our answer for that one. Okay, how are we doing? Do we see the method to the madness? You're like, sure we do, sure. Okay, I have a couple more problems. The next one is a bit easier than these. Yay, we need a little bit of a break, huh? All right. I'm just going to pause here for a second, let you catch up with me. Okay, are we all good? Okay. So let's look at this one. Okay, we have a rectangle that has one corner in quadrant 1 on that graph. So it looks like we have a little helper equation right here. There's our little helper equation. Another at the origin, a third on the positive y-axis, a third on the positive x-axis. So it's describing the picture that you're seeing there. That's all it's doing. Express the area A of the rectangle as a function of x and find the maximum value of A. Okay, well, we can do that. So this right here would be x, right? I mean, that's our x coordinate. This right here would be y. And so they want us to do area. We know what the formula for area is. Area would be, with my variables, x, y. I'm not allowed to have two different variables, right? Not allowed. I need to, sub in. I need my little helper equation. This is my little helper. So I'm going to take the y out, and I'm going to put in the 25 minus x squared. So 25 minus x squared. There's my equation. And it asks me, express the area A as a function of x. We just did that. So this is an answer. Now, you can distribute and combine like terms if you want to, or you can leave it factored. Doesn't really matter. Both of those are fine ways to leave your answer. Factored or multiplied out. Okay, now what do they want us to do? They want us to find the maximum value of A. Well, what would we do? We're going to put that equation in our calculator. Now, just for time's sake, I'm not going to pull my calculator up again. I think we're pretty comfortable putting stuff in the calculator. So I'm just going to draw you a picture. So when I put it in my calculator, it looked kind of like that. And I found my maximum value. My maximum value was 2.8868, comma 48.1125. Okay, that's what I got off my calculator. Okay, that's what I got off my calculator. I wanted to find the maximum value. The maximum value is the maximum y value. This is my area. So area right here, this is like in my calculator, this is the y value. Right, my area, this in my calculator, that's the y value. So that's what we want, that's the maximum area, which is what they want us to find, the maximum value of the area, which maximum area. So my area max is 48.113, and they don't give us any units, so we're just going to go with that. Now that one required two equations also. It required our area equation, x times y, but then we had to, use a helper. Okay, how we doing? Okay, the next one is weird, and you're like, what? Those weren't weird? Okay, this one is actually gets the prize for being weird. I'm just gonna say. We've got a cylinder inscribed in a sphere with radius 5. Okay, so I'm going to, now I know, I bet every person in here is a better artist than I am, so I already apologize for the way my figure is going to look. I'm just going to do the best I can. So when I draw a sphere, I usually draw a circle with this little thing, you know, because we're trying to draw in 3 dimensions, with that little thing in the middle. That's what I usually do. That's kind of my sphere. That's my go-to sphere. The sphere has a radius of 5, so I'm going to go ahead and just mark that. So that radius is 5. Okay, great. We have a cylinder inside of it. I'm going to draw the cylinder in a different color just so you can tell the difference between the drawings. So the cylinder would be touching the sphere at its corners. That's what it would do. If it was inside the sphere like that, it would be touching at the corners, and I don't know, it kind of look something like that. Something like that. Okay, so we've got a sphere with a cylinder inside of it. It says, express the volume of the cylinder as a function of x. X is the perpendicular distance from the center of the sphere to the top of the cylinder. So this is x. The distance from the center of the sphere to the top of the cylinder. Okay, before I go any farther, I want to look at the volume formula. We're dealing with volume of the cylinder. They want the volume of the cylinder. So I need the formula for the volume of a cylinder. That's what I need. Okay, so hopefully we remember that formula. Volume of the cylinder. That little c just means cylinder, so we don't get confused with sphere. Is area of the base times the height, so pi r squared h. Okay. So I need to figure out how to put stuff in terms of that weird x. I want to actually also put the r in this formula is not the r for the sphere, it's the r for the cylinder. So I'm going to draw that in. That's r. Now, we know the radius of the whole sphere is 5, so if that's 5, so is that. That's 5 also. So what I'm going to do is I'm going to pull out that triangle because it's too much going on in that figure. Let me just kind of highlight. So this is a little triangle right here that I am pulling out. That's this. Just so we can analyze it a little bit better away from the drawing. So that's r, and that's x, and that's 5. Because that's also the radius. From the center of the sphere to the edge is 5. So I know I can use Pythagorean theorem to set up a relationship between x and r, so that's what I'm going to do. So we've got x squared plus r squared equals 5 squared. And they want me to make it in terms of x. So I want to solve for r squared. So r squared is going to be 25 minus x squared. Now I'm going to take this r squared and replace this r squared. I'm going to pull out that r squared and replace it with a 25 minus x squared. Okay, the things I have highlighted in blue, I'm going to replace that r squared with 25 minus x squared. So I have the volume of the cylinder is pi, Let's open up that spot and put 25 minus x squared in. Now, I can't use an h. I can't use an h. I need some kind of an x. Let's look back at our figure of the cylinder. Since the distance from the middle to the top is x, wouldn't you agree with me that the distance from the middle to the bottom is also x? Would you agree with me there? That has to be the same. So my height is actually x plus x, which is 2x. So my height is actually 2x. Okay. There is step 1. Express the volume of the cylinder as a function of x, which is the perpendicular distance from the center to the top. Now they want us to find the domain. So let me tell you how easiest way to find the domain. To find the domain, I'm going to set each of these equal to 0. Set them in factored form. Set equal to 0. So 2x equals 0, so x is 0. So my domain starts at 0. 25 minus x squared equals 0. X squared equals 25. X is plus or minus 5. We know that when we're talking about a cylinder, we can't have a negative side or anything. So the negative 5 isn't going to help. So our domain is 0 to 5. And that's the second check. We got the domain and we got the equation. All right, part B, find the value of x that maximizes the volume. So we would just take this is my equation right here. I would put this in my calculator, the one I've highlighted in yellow. I put it in my calculator. I'm not going to pull out my calculator, I'm just going to show you. So I would get something that looks like this. And the maximum is going to be, that point is 2.8868, 302.2999. So find the value of x that maximizes the volume. Well, x is the 2.887. And we don't have any units, so that's where we leave it. Maximum volume is this y value of 302.3. All right.